Hello, applied calculus students, Math 150. I am looking at section 4.4. We have already looked at the first and second derivatives. Now we're going to concentrate on the first derivative and finding the maximums and minimums. And that's what these applications are going to be about. In the next few sections, we're going to be looking at maximums and minimums. So number one, an outboard motor has an initial price of $3,200. A service contract costs $300 for the first year and increases $100 per year thereafter. The total cost of the outboard motor in dollars after n years is given by C of n, here's our function, 3,200 plus 250n plus 50n squared. Then it says, write an equation for the average cost per year, remember that's the C bar, of n for n years. So we're not used to having n, we're used to having x here, which is that production. Here's talking about a contract for n years. I ask you to graph C bar, but I'm going to do part C first. These are kind of reversed. So we're going to use calculus to determine when is the average cost per year at its minimum. So again, we're looking at maximums and minimums, and then we'll write the meaning of what we obtain. So first of all, let's start with our C of n, right here. C of n is equal to 50n squared. I turned the equation around. Plus 250n plus 3,200, where n is in years and c is the cost in dollars. Your average cost, remember you take this function, the cost function, and divide by n in this case. And what we're going to do is find the minimum of this function. Now, finding minimums requires taking the derivative. And before I take the derivative, I thought instead of using quotient rule, I'm going to show you another way. When it's something like this with a single denominator, so you don't have to do quotient rule, you can just take each term and divide by that single n, like this. So 50n squared over n, 250n over n, plus 3,200 over n. And then your C bar, your average cost, is equal to the n's cancel, and you get 50n plus these cancel completely, 250 plus, and because I'm going to take the derivative, I'm just going to rewrite that like that. And then it's ready for just using a power rule. So now again, I'm doing C first. I'll come back to that picture. Take the derivative. So C bar prime of n is, well, you take the derivative of that, it's 50. The derivative of that goes away. And the derivative of this, you're going to take the negative 1 in front. You get negative 3,200. Into the subtract 1 is negative second power. So my derivative is 50 minus 3,200 n to the negative second power. And we're going to set it equal to 0. So remember, you take the derivative, set it equal to 0 to find your critical values. Now this looks more complicated than it is, but remember that negative 2 power, we can put it in the denominator by one of the rules of exponents, the negative exponent rule. And then I just added that to both sides. And this is where I would just call it cross multiplying like this. Put this over 1. So I'm going to go 50 times n squared equals 3,200. And then you get rid of your denominators. Now what do? You divide both sides by 50, right? So I'm going to divide this by 50, divide that by 50. And when you do that, you get n squared equals 64. So work along with me. Pause this if you need to make sure you're getting exactly what I'm getting. And then when you square root, if you're trained, you should have a plus or minus here. Now n equals plus or minus 8. The square root of 64 is 8. And since we're talking about a number of years, we're just going to use the positive. So this is the critical value. And so after 8 years, that's what this is. This is giving us, after 8 years, we've found our minimum average cost. Now, find the cost. We're going to plug the 8, the average cost, We're going to plug the 8 into, well, we've got some choices. We could plug it into this one here. Okay, just put an 8 in there, square times 15, all those divided by 8. Or you can put it into this simplified one. I'm not sure which one I did. I put it into 50 times 8 plus 250 plus 3200 times 8 to the negative second power. And that gives you 1050. And this is, cost is measured in, what is it measured in? Dollars. But average cost is per unit. So this is going to be per, in this case, year. So it's the average cost of keeping that outboard motor is costing $1,050 per year. All right, so what I'm going to say is after 8 years, the average cost of the outboard motor is at a minimum. You want to throw that in because that's what we're looking for, the least average cost of $1,050 per year. Now to graph this, I gave you the window. I said to graph it 0 to 20 by 50, 0 to 3500 by 500s. So you would do that in your calculator and put, what are we putting in? You're putting in C bar, the average cost. And that's what this looks like. I did the years on this, and this is dollars. Okay, years in dollars, and this is C bar of X. And notice that your average cost from the beginning goes down to a minimum, and then your average cost starts to go up, and that is your minimum. So if you put this in your window and graph it correctly, you will have that picture. All right, I'll be back with example 2.